In this example, we'll be looking at how you can apply Gay-Lussac's law to solve gas law problems. So Gay-Lussac's law is the law that relates pressure and temperature, and it tells us that with gases, pressure and temperature are directly proportional. So if one increases, then the other has to increase. So this question says, if the pressure in a container is 452 kilopascals at 230 degrees Celsius, what will its pressure be when its temperature is 821.9 degrees Celsius? So first, we know that this is a problem relating to Gay-Lussac's law, so we will we'll start off by writing our equation. P1T2 equals P2T1, and then we'll start to set up a data list. So we know the initial pressure is 452.0 kilopascals. The initial temperature is 230 degrees Celsius, which we're going to have to convert to Kelvin. The final temperature is 821.9 degrees Celsius, which we'll have to convert to Kelvin. And then the final pressure is our unknown. So that's what we're going to figure out. So just to make this more quick on ourselves, when we're going from Celsius to Kelvin, we add 273.15. So that's just going to make the initial temperature 503.15 Kelvin, and the final temperature 1095.05 Kelvin. Our next step is to look to the Gay-Lussac's law formula to figure out what we want to solve for, what algebra we need to perform. So we are asked for the final pressure, which means we're going to have to isolate P2 on one side of the equation. So we can achieve that by dividing both sides by T1. And then we'll get P2 on its own being equal to P1 times T2 over T1. And then we will just sub in all of our information. So 452 kilopascals times 1095.05 Kelvin divided by 503.15 Kelvin. So then when you type all that into your calculator, you're going to end up with a final answer of about 983.73 kilopascals. And then we can just say therefore the final pressure in the container is 983.73 kilopascals. Something to keep in mind for this question as well is that given that we are only told units of pressure and temperature, and that's all we have to work with, we assume the volume is constant. Because if the volume was not constant, then you would need to apply a different gas law, which will, Charles' law relates to volume, but we'll be seeing other gas laws in the future. So when dealing with just Gay-Lussac's law problems, then we assume volume is constant. And you'll know what assumptions you kind of need to make to solve them based on the information given in the question.